All right, so we're going to be solving systems algebraically. Still the same three scenarios can happen. What are those three scenarios? One solution. Yeah. No solution. Or three, infinitely many. All right, and the words that went with those, the math words, one solution was consistent and independent. No solution was inconsistent, yeah. And then infinitely many was consistent because it had answers, and dependent. Those were the mathy words that went with it. We're normally going to say these three things, but understand that those words exist, and you need to tie those together. All right. So with solving systems algebraically, this is something that we go over in Algebra 1 quite a bit with two variable systems. We're going to be building up to doing three variable systems and things in here. So a little larger things, but we're going to learn some new tools in here. The first day, like today, we're going to be talking about using substitution and elimination, the same two methods that you used in Algebra 1. And on the quiz for this, that I would expect you to show me, using substitution or elimination to solve that. Okay, we're going to learn some other rules you may already know, that you can use your graphing calculator to solve these, and that's wonderful, but you still need these skills for when we do nonlinear systems. So that's why we go through the skill of actually solving them that way. So because nonlinear systems don't work with the graphing calculator on the matrices as well. So we're going to solve using substitution first. Start with something pretty easy. Y equals 3x minus 2. And then the second equation is x plus 2y equals 10. So this one is a prime candidate for substitution because you have one of the equations with the variable by itself. That's what makes it a prime candidate for substitution. So I could take that 3x minus 2 and substitute that for what? I could not x and y, but y in the bottom, because it says that y equals that. So that means that I can replace any y that I see in the other equation with this. So I'm going to replace that and have x plus 2 times 3x minus 2 equal to 10. And then we get a regular algebra equation to solve, something that we've done hopefully a lot of over the years. So distributing the 2, x plus 6x minus 4, and then solve it for x. It's basic algebra, pre-algebra stuff. So be 7x minus 4 equals 10. Add 4. 7x equals 14. Divide by 7. And x is 2. If x is 2, how do we find y? Yeah, plug it into one of I'm going to use the top equation because it's the easiest, but it doesn't really matter which one you use. Just pick one, plug it in there, and work it out. So the top one, if I go y equals 3 parentheses 2 minus 2, it'd be 6 minus 2. So y is equal to 4. Ordered pair solution, 2, 4. What does that mean about the graph of these two equations? Do they cross? How many solutions do we find? One. So one solution, remember we talked about one solution. If you got two lines, one solution, those lines are crossing. Where are these two lines crossing? At 2, 4. So that's what we're finding. We're finding where the lines would have crossed if we graphed them. out of this. So that's what we're trying to find. All right. So let's look at one. Maybe it's a little tougher. Not much. But 3x plus 2y equals 1. Then negative 2x plus y equals 4. And we're still going to do substitution here. Well, this one, we don't have a variable by itself, but we could get one pretty easily, right? With which equation could I get a variable by itself pretty quickly? The second one would be the easiest, right? Because all we got to do is move the 2x, right? How do we move that 2x? Yeah, add 2x to both sides. Oops, 26, 2x. That's going to be 4, or I'm going to write it in slope-intercept form, 2x plus 4. And then what am I going to do with the 2x plus 4? Put it in there for the y and the 2y. That's right. 3x plus 2 parentheses 2x plus 4 equals 1. So I'm just substituting 2x plus 4 for y in the other equation. Okay.
Brianne Sappington, please report to the office.
Can't go back into this one because that's the one I got it from. We're just going to go in circles if you do that. Just cancel everything out. Doesn't work that way. So you got to go into the other equation, work that. That'd be 4x plus 8. And then the 3x is still there. 7x plus 8. Subtract 8. 7x equals negative 7. So x would be negative 1. And how can I get y? Plug it into one of those equations that's up there. Which one would be the best one? Yeah, that one right there. As long as you didn't make a mistake getting y by itself, you're good. Plug it in there. It's the easiest work. So y equals 2 times negative 1 plus 4, which is 2. So the ordered pair solution is negative 1, 2. And that's what we're looking for at the end, is an ordered pair solution to the system. All right. Pretty nice. Easy stuff, right? 12x minus 3y equals negative 9. Negative 4x plus y equals positive 3. Keep in mind, you don't always have to solve for y on one of these equations. If it was like plain x plus 4y, you could easily solve for x and plug in for x. Out of that. Still doing substitution on this one. We'll do elimination in just a second and knock that out. Be done for the day. All right, so what do we do? Get y by itself. How do I do that? Well, you could. Gabe said subtract the 12x, so we could get y by itself on the first equation or the second equation. I think the second one probably be quicker and with less division involved, so I'm going to do that one. But it doesn't matter which one you do that, so that's absolutely legal to do that. So that's going to be y equals 4x plus 3. Then we take that and plug it in for y. Distribute. What happens on this one? So I just end up with negative 9 equals negative 9. -9 equal -9? Yeah, this is true. When it's true, that means what? No. Infinite. Infinitely many solutions. If that were something like 8 equals -9, and that's not true, that would be no solution. So if your variables all cancel out, no matter which method you're using, whether you're using substitution or elimination, if the variables all cancel out, you look at what's left. If it's true, if the numbers are equal on each side, then it's infinitely many solutions. If it's false, then it's no solution. Okay, so that's, the exceptional ones. So with the graph of this, if we had graphed both of these original equations, what would the lines have been doing? They'd have been right on top of each other. So if we'd have got y by itself on the first one, what we would have noticed is that this equation would be y equals 4x plus 3 as well. So that if we got y by itself on the first one, it would be the same equation. So there's substitution, very, very good method for solving systems. Every system that can be solved with substitution. Some are harder than others to do with substitution. I like elimination a lot. I think Coach Mack is a big substitution guy. He does substitution most of the time. I like elimination a pretty good bit. I mean, you got to be able to do both, because there are times when elimination really just is easier than substitution. There are times when substitution is really easier than elimination. So when you're looking at doing elimination, you're trying to eliminate one of the variables by combining the equations. So like this equation, you got 3x minus 5y equals 10, and then 4x plus 5y equals 4. So with this, what really stands out and says, hey, you need to do elimination on this problem is the fact that it wouldn't be easy to solve for one of the variables here. You'd end up with some fractions either way, right? We try to avoid those if possible, right? Because nobody likes working with fractions. Or if you do, maybe, you could if you wanted to. But I look at this, and what do we see happening here with the y's? Yeah, one's positive 5y, one's negative 5y. So they're opposites. That's the key, is that you have to have opposites for something to eliminate. So if I added these two equations together, and I always add when I'm doing systems of equations, I add at the end. So these two would cancel each other out. Negative 5y plus positive 5y, it's gone. And then 3x plus 4x would be 7x. 10 plus 4 would be 14. And then we got a one-step equation to solve. Ooh, that's easy, right? Because x would be what? Yeah, 5 by 7, x would be 2. That's why I like elimination. One-step problems to do. And then, how do we get y, though? Not as easy to get y with elimination. So you've got to plug that x in somewhere. You pick your poison, whichever one you think's the easiest. I usually just by default, because really none's easier than other, I just go to the top one and go, okay, well, that's 3 times 2 minus 5y equals 10. Because I'm fairly confident in my ability to solve 3-step problems. That's 6 minus 5y equals 10. And then I would divide by, or excuse me, subtract 6 and then divide. Negative 5y equals 4, divide by negative 5. Negative 4/5 is y. And here's a prime example of why algebraically is a little bit better than graphing. If I had graphed these two equations, they cross at 2 and negative 4/5 as the ordered pair. Eyeballing negative 4/5 on the coordinate plane is pretty tough. I couldn't glance at your graph and tell the difference in negative 4/5 and negative 5/6. There's very little difference in those two when you're eyeballing it. So algebraically, we get the exact place they cross. Graphically, you'd have to make a guess as to what's that fraction going to be. So you'd have to kind of guess at it because it would be almost -1, but it's not quite. So elimination is wonderful. Let's look at this elimination problem. 3x minus 7y equals 10. 3x minus 4y equals 4. Very similar problem with one major difference. Do we see opposites in this problem?
No.
No, but do we see the same or similar numbers on one of the variables? Yeah, the 3x is there. To get those to cancel out, one of them needs to be what? Negative. So let's make one negative by multiplying that entire equation by -1. Remember doing that in Algebra 1, hopefully. If I multiply this by -1, I have to do the entire equation. I can't just do one part of it. And that's where most people make mistakes is they forget to do the whole equation. And that's going to turn it into -3x plus 4y equals -4. And the top equation, I didn't have to do anything to. So I'm just going to copy it over. And then add them together. The x's do what? Cross each other out. They're gone. And we have -7y plus +4y. -3y. And then 10 minus 4, 6. And we get a one-step equation to solve to get a variable. That's what we want. Divide by -3. And y is -2. That's nice. How do we get x? Plug y into one of the equations. Pick which one you think is the easiest. I'm going to go with the first one. 3x minus 7 times -2 equals 10. No matter which equation you pick, you should get the exact same answer for x. Okay, so that'd be 3x plus 14 equals 10. Subtract your 14. X equals -4. Divide by 3. X is -4/3. Ordered pair solution, -4/3, -2. Again, that ordered pair solution is what we're after at the end here. Those two lines would cross at that point. All right. Not too bad. Easy stuff. Three x plus 3y is -15. 5x minus 9y equals 3. What could we do to this problem to make opposites happen, Caleb? Yeah, and that would get us opposites on which variable? The y and the -9, right? So if we multiply this top one by 3, that changes it to 9x plus 9y -45. And then the bottom one doesn't need to change. We're just trying to get those opposites there. Let me tell this to postpone for about an hour. I don't plan on teaching for another hour, but anyway. Once I have the opposites there, do elimination, add them together. They eliminate one another. 14x equals -42. Divide by 14. How many times? 14 going to 42. -3 times. There's x. Pick one to get y. It doesn't matter which one. Go to the top. Negative 9 plus 3y. And I'm showing every step here, like I would hope that you would on your quiz. Negative 15 plus 9 would be negative 6. And y would be negative 2, right? Division. Y is equal to negative 2. Ordered pair would be negative 3, negative 2. Easy peasy. All right, very good. So there we had to multiply one of them by something other than a negative 1 to get opposites happening. Let's get opposites happening and do elimination for this one. 8x plus 9y equals 15. 5x minus 2y equals 17. Not quite the easy thing like example E and F were. Because there's not a nice integer that I can multiply by and turn a 5 into an 8 or turn a 2 into a 9. So I've got to think, okay, what do I do? And I got to first pick which letter I want to eliminate. Which one we want to eliminate here? Y would look good because they already got opposite signs. So that'd be, that way you don't have to introduce a negative. So that seems like a smart thing to do. So what do 9 and 2 have in common? 18. So just turn them both into 18s. So the first one we would need to multiply by 2. The bottom one we need to multiply by 9, right? Won't always be the same number if you're going to get the smallest one. Okay, the smallest one is not always the product of those two. So that'd be 16x, 18y, 30. This would be 45x, negative 18y, bless you, 90 and 63 be 153. So nice, fun, larger numbers. Now we can cancel out the y's and total those up. So 61x, 183. Divide. That goes 3 times. And then go from there. Plug it back in. Pick whichever one you want to. I'm going back to the first one. I don't like to do anything different. Subtract 24. 9y is negative 9. Divide. Y is negative 1. Negative 1, 3. And there we have it. It's an ordered pair solution. Okay. Not bad. Easy stuff. Multiplying both equations by something. One last example, and we'll be done for the day. $15x plus 12y equals 11. Negative 5x minus 4y equals 8. What do we do to this one? We multiply the second one by 3. That'll eliminate what? Is it by, not by negative 3, but by 3? It ends up in eliminating both of them. All right. 4 15x plus 12y. So if it eliminates both of them, is it? What's left on the left side? if everything's eliminated? 0. Nothing is left on. If everything eliminated itself, there's a 0 left there. Does 0 ever equal 35? No. That'd be no solution. Now, if it turned out to be 0 equals 0 on the other side, then that's infinitely many. But here, because all the variables canceled out, we look and see, okay, it's nothing equal to 35. But no, it's not. 0 is not equal to 35. 0 is equal to 0. All right. Okay, so let me kind of pose a scenario to you. You can get your assignment today. You're going to have about an hour here in class. And then what I'm thinking is that we quiz tomorrow at the end of the block. That gives you the rest of the day to work on this assignment. That way we don't have a quiz Monday morning when we come in. Is that okay with you guys? I know some of us have got makeup stuff to do, and we're going to talk about that in a second. And I know, JP, you got your test tomorrow. That I think you'll probably be fine and be done before that happens. But you know, if it's not, we'll work with skinny block. So that's what I want to do, just to keep from having a quiz on Monday morning, because you know Monday's rough enough. Let's try to avoid that if we can. All right, so 3 through 39 odd. So that'd be 15, 16, 17 problems. It's not many. So make sure you're practicing both substitution and elimination. I will ask you to do, you know, maybe one or two with substitution, 1 or 2 with elimination, and then I'll have some, like, you know, the next 6, you can pick which way you want to do it. Okay, so, and some of those would probably lean better toward one method than the other. Okay, so that's what we're working on today, and trying to be prepared for a quiz tomorrow toward the end of the block. All right. If you want to do it now, or would you rather do it in school? Now it's fine. Okay, that's fine. All right. Gage and Johnson, I guess you guys need to see about what we need to do to get stuff caught up. What do you need from me? And all that.